Okay, so let's turn to visualization. That's our most powerful technique for data exploration. So in one dimension, we have methods to look at distributions of numeric variables. We have what we'll call frequency tables or in charts to look at the categories of categorical variables. In 2 dimensions, we can do a number of things now. We can have 2 numeric variables on, say, a vertical and horizontal axis. We can have a categorical and a numeric variable. So we can have a categorical variable on one axis and a numeric variable on another axis. That's very common. We'll show you lots of examples of that, and you'll work with some. But there's a serious problem with visualizing complex data. We have many variables, but we're stuck with a 2-dimensional computer screen. I have a 2-dimensional computer screen in front of me. You probably have a 2-dimensional computer screen in front of you, unless you're like using a VR headset or something, and maybe you have 3 dimensions. But basically, most of us are stuck with 2-dimensional displays that we have to use to visualize very complex, very high-dimensional data. So what do? Well, our first tool we go to is something called aesthetics. And I'm going to present these aesthetics to you in order of best to least human perception. So there's been a lot of research on this by academics on what aspects of statistical or scientific graphics people understand the best, right? So keep that in mind when you're thinking about what aesthetics to use. So the most generally, there's general agreement on this, although you'll see exceptions in the research literature, but almost everyone agrees that humans are very sensitive to knowing position. If you have an XY scatter plot and you have 2 points that are slightly different positions from each other, you'll see that, right? You know this one's a little higher and to the right, or even if it's a tiny difference, you're very sensitive to that, and most people are. Length, similar to position, humans are really good at judging and understanding small differences in length. So we use that in certain scientific graphics. Shape. We are good at telling the difference between different shapes. And so we can take advantage of that as an aesthetic. We can use different, what we call marker shapes when we're building scientific graphics. But don't overdo this, right? You can only tell the difference between a handful of shapes, maybe 6, 8 shapes. If you start having lots of shapes that are very similar, it's just going to be a big mess. Size. We're pretty good at telling size of markers apart as people. So you can use size pretty well. And size is useful to get a 3rd dimension on your plots. Color. Color is a 2-edged sword. Notice it's at the bottom of my list. So we're not so good at small differences in color as humans. We're hue, which I didn't put on the list, we're good at. Like if we have shades of blue or shades of gray, we're fairly good at seeing small differences in that. But the difference between two types of red or something like that, we're not so good at that. So when you use color, use it sparingly. Only use a few clearly distinct color. Also, keep in mind that many people, especially men, are red-green colorblind. So if you're trying to get them to tell the difference between red and green all the time, they may not see it at all. So let's talk about this. So position can be used for categorical and numeric values. Length can be used for numeric or categorical values if the categorical values have some order. Shape, generally for categorical variables. Size, generally for numeric variables, although you can also use it for categorical variables, again, if they have a rank order. And color generally for categorical variables, but hue can be used for numeric. So there's one other way we can deal with this problem of being stuck on our 2-dimensional computer screens, and that's to use arrays of multiple axes. And we'll look at 2 different methods for doing this. One is a multiple axis plot, where we say create an array, a scatter plot, what we'll call a scatter plot matrix. And another is to use what's called, it goes by different names because it's been invented a number of times by different researchers over the years. Conditioned plots, faceted plots, small multiple plots. They're all the same idea. The idea is you build an array of plots, but rather than showing all the data or just certain dimensions like a multi-axis plot, you're doing a group by operation. So maybe you're grouping by some other categorical variable or variables to just show a subset. And so you see subsets side by side or top to bottom, and that gives you a way to drill into really complex relationships in data. So I hope I've given you an overview of why you must and should explore data, some tools you can use to explore data, and a little bit of background in the theory of how we explore data and how we can go beyond being stuck in 2 dimensions.